So this is the semi-log paper graph, right? Semi-log paper, and it's called semi-log because it's half in log scale and another half is in linear scale. So one axis in log scale, one axis is in linear scale. So here we have this is the log scale and this is the linear scale, but you have to make sure that you are looking at the graph paper in the correct position, because this one is wrong, right? It's actually this way, right? So how to know which one is correct, which one is wrong? You just have to look at the scale of the y-axis, or sorry, the x-axis. So let's just say this is 1. Okay, now the next line is 2, so the next line is 3, 4, 5, and so on until this is 10. So it's usually in log scale, 1 and 2 we have large gap here, large distance, and the second one is 2, 3, and the gap or the distance is getting narrower, right? It's getting smaller. 2 and 3 is smaller than 1 and 2. 3 and 4 is smaller than this one is smaller than this, so it's getting smaller until you reach 10. And next after 10 is 20, alright, not 11. So 20, 30, and so on until 100, and so on until, so this will be 100, this will be 1000, and so on. So if you are holding your paper in this direction, if you think this is 1, this is 2, so that is wrong, right? You can check yourself using the calculator for the log scale. And for the y-axis, this is in linear scale. So if you assume this is 0, this is, this is 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so 20 and so on. So this is the linear scale. So that's how you determine which is the correct direction to hold, to look at the semi-log paper. Now let's draw the magnitude plot for this transfer function. Right, so we have 4 factor. Alright, let's draw 10 as 1 over 1 plus s over 2 and 1 over 1 plus s over 10. Let's draw all these 4 factors. The first one is 10. So 10 is just replace k with 10. So we got here 20 log 10 10. Now that is, if you look at the calculator, the value is 20. Okay, so here 20 log 10 10 is 20 decibel. That's the magnitude, right? So we know because of factor k is 10, so for the magnitude plot we will have a straight line at 20 dB. Okay, now I think the best way is to kind of sketch the shape before you plot on the actual semi-log plot. So for k, k equals to 10, you will get a straight line 20 dB. Alright, so let's look at when this is the first factor, second factor is S. So for S, what we have is a straight line with 20 dB per decade crossing at 1. So we will have this. So this is 1. And magnitude is the slope is 20 dB per decade, right? And the third one is 1 over 1 plus S. Plus 2. Alright, so in this case, look at this factor. So we have this one starting at 2, we will have a negative slope, right? So this is the x-axis, this is 2, right? Going down, and this is negative 20 dB per decade. And then the fourth one, 1 over 1 plus S over 10. Okay, so same shape. Now is at 10 radian, which is the angular frequency. Angular frequency 10 radian, right? So again, negative 20 dB per decade. So we have to draw all this on the semi-log paper. So we know that there's a straight line crossing at 1, crossing at 2, crossing at 10. So we kind of get the range that we need to draw, range for the semi-log. So this is the center of the paper. So we will draw a straight line here. So this will be marked as 0. This is 0 dB. And then, so we will take this as the 1 at 1. Alright, so this will be 1. Okay. I have my ruler here. We will draw the first one, which is 20 dB. So 20 dB. So it's up to you if you want to take this as 10, and this is as 20, or this is 20, this is 40. But I guess because that because this will go up first and then go down and then go down again, I think yeah, we will take this as a 10 and 20. Right, this is 20 dB. For each factor, you may draw a dash line, right? Do not draw, I don't think it's good to draw a solid line. Just draw the dash line, right? So this will be for the K or the 20, right? Log 10, 10, right? The next is the second factor, which is S, crossing at 1, right? So this is 1, and the second dot is here, will be here, alright? because from here to here that is 20 dB, and here to here is 1 decade. 1 decade is actually 1 to 10 or 10 to 100 or 2 to 20, right, or 40 to 400. So that is considered as 1 decade. So in this case 1 decade is from 1 to 10, so that is 1 decade. So 20 dB per decade. So let's draw the straight line for this factor. Okay, draw. So that is for S. So that is the S. Now let's draw the third factor, which is this one. Okay, add 2 radian. So this is 1 radian crossing at 0 dB. So next is 2 radian crossing at 0 dB. That is 2 radian. 1 decade is 20, right? 20. So this is 1 decade, and 20 dB is because it's a negative slope, so we have to take the negative 20. So this to here is 20 dB, so this to here is negative 20, right? So negative 20, this is the location, the point, right? So that is for, oops, sorry, this should not, remember that is factor is straight line here before P or before 2, so is for through is straight line like that. So this is 1 over 1 plus S over 2. So next is the final one, which is crossing at 10. So this is our 10, this is here, and for 1 dB it will be here 100, alright. So here is that is 20 dB. So from here to here, that is the line for one over one plus S over 10, right? So we have 4 factors here. This first one is 20 dB. This is the S factor. This is the 1 over 1 plus S2, 1 over 1 plus S over 2. And the fourth one is 1 over 1 plus S over 10. So this is 10, this is 2, this is 1. Okay, now we can draw the, we can combine all plots. Okay, so first of all, before here, before 1 we have a straight line 20 dB per decade, and we have a straight line here with 0 slope. So what happened here is this line will be shifted up as much as 20 dB, right? If you have this line plus this line, you will get this line, right? You will move this line up to here because of this line now, right? So this one bring here plus 20 dB, this one plus it plus 20 dB. So that is the, now we can draw solid line. Alright, so before 1 radian we have 20 dB, we have straight line here 20 dB per decade slope, and this one is 0 dB and 0 dB from these two factors. Alright, so in total we have this line move up by 20 dB. Okay, so here until at this point we have a new factor which is 1 over 1 plus s over 2. Now this factor will affect this line, right? Before this is a 0 dB, so it doesn't give any change to the line. So now starting at 2 radian it will give some effect, but it will change the line here. So we know that if this is for here, this is 20 dB per decade plus minus 20 dB per decade. Alright, what we have is a straight line because this slope and this slope will cancel out each other. Right, so we know that starting at this point is just a straight line with zero slope. Right, alright, we can delete, we can remove this. Okay, so continue to look at higher frequency. This is 2. Now as 10 we have another slope, we see another slope, negative 20 dB per decade. So because of this line, it will give effect to the total line here. So now this will go down, right? So this is, I would say, about 4 over 10, right? So here, so this is 1 dB, this is this is 10 dB, 20 dB. Alright, or you can try to estimate the distance here, right? So from here to here is 1 decade, so this is 10 dB, so this is 20 dB. Try to estimate the length here, right? And then length here. So this is 20 dB. So you can draw the line. So that is the total line, or the total complete magnitude plot So that's the total or the complete magnitude plot for the transfer function.